Alright, so let's take a look at the second example, finding the surface area of a function revolved about an axis. So here we have the surface area of the surface obtained by rotating the curve y equals f of x from a to b about the x-axis is this. The surface area is the integral a to b 2 pi times f of x times the square root of 1 plus the derivative squared. And that's with respect to x. We're integrating with respect to x. All right, well, sometimes you might revolve about the y-axis. So if you have a function x equals g of y, okay, let's say we're in terms of y, all right, and we're going to revolve this surface about the y-axis from, let's say y is from c to d, okay, and this is about the y-axis. We're revolving it. So our surface area would be, well, it's the same thing as this. It's c to d, okay, we're going from c to d. And the 2 pi, yeah, the 2 pi is in here, but what I like to do is I like to just bring the 2 pi outside. Okay, bring the constant term outside the integral. A lot of times it just makes it easier. And then that's going to be x times the square root of 1 plus. Now, we're taking the derivative of x with respect to y. Okay, up here in this scenario, your derivative f prime x, that's like dy dx. But this time x is equal to something in terms of y, so your derivative is going to be dx dy, the derivative of x with respect to y, and that's squared, and we'll be integrating with respect to y. So it's times the dy. All right, so let's go ahead and take a look at our example. All right, so find the surface obtained by rotating the curve about the y-axis. Okay, let's go ahead and just write our formula down. So S is, and I'll bring the 2 pi out here, that's c to d x square root 1 plus the derivative of x with respect to y squared dy. All right. All right, so we need the derivative of x with respect to y. Well, here I have y equals, and that's the cube root of x. So this tells me that x is equal to y cubed. If I cube both sides, I get x equal y cubed. So the derivative, the dx dy, the derivative of this is 3y squared. That's the derivative of x with respect to y. All right, so now we just plug everything in, and you can see our limit c to d, that's from 1 to 2. Okay, and see it's the y values. All right, so the surface area is 2 pi, and we're going from 1 to 2 of x. Well, what's x? It's y cubed. Times the square root of 1 plus, and then the derivative squared. So dx dy, that's 3y squared squared dy. Okay, and so s is 2 pi from 1 to 2 y cubed square root of 1 plus 9y to the fourth dy. All right, so to integrate this, well, hopefully you can see that this will be u substitution. Okay, so we're going to let u equal 1 plus 9y to the fourth. Okay, what's underneath the radical? And du is going to be 36y cubed dy. All right. So if you look at this, see my y cubed and dy? Well, there's my y cubed and my dy. Okay. But I'm missing the 36 out here. So what I'll do is I'll multiply by 36, and since I multiplied by 36, I need to come out here and divide by 36. And so that's going to give me S equals pi over 18, okay? And look, the 36y cubed dy, the 36y cubed dy, that's du. And then I'll put u in for 1 plus 9y to the fourth. So that's going to be the square root of u. I plugged the u in for this. 1 plus 9y to the fourth. And then 36y cubed dy, that's here. That's du. Now, since I changed my variable to u, I have to also adjust my limits. See, these limits are y values. I need u values. So, come over here, for this upper limit, u is equal to 1 plus 9 times 2 to the fourth. Okay, and that gives me 145. Okay, so this would be 145. And then for the lower limit, u equals 1 plus 9 times 1 to the fourth, which that is going to give me 10. And so there's 10. And also what I'm going to do to integrate this, s is pi over 18 from 10 to 145, and we'll change the radical to a 1/2 power. Alright, so now we're ready to integrate. So the surface area is pi over 18, and that's u to the 3/2, add 1, then multiply by the reciprocal of the exponent, so that's 2/3, and that's from 10 to 145. And so this gives me a surface area of pi over 27 times u to the 3/2 from 10 to 145. And I like to, if there's a coefficient out here, I like to separate it from this when I plug the numbers in. You don't have to do that. I just think it kind of makes it easier. So that's pi over 27 times, that's going to be 145 to the 3/2 minus 10 to the 3/2. And this is your answer. And yeah, if you wanted to, you can just punch that in your calculator and get a decimal answer. That's fine. But I guess you can leave it like that too. Whatever your teacher wants you to do. Alright, so check out my other calculus videos. I got a bunch of videos on my website. Give me a subscribe, like, and share, and thanks for watching.